As promised, today we're going to take a look at what's called a phase shift for transformations for sine and cosine functions. What that really means is a horizontal shift. How that happens is if you are adding or subtracting something to the x inside the parentheses before you take the sine or cosine of that value. So on the outside, plus or minus would be a vertical shift, or inside would be a phase shift for any trigonometric function. So taking a look at our setup, now we've got that plus c inside the parentheses in the asylum. For those of you that are familiar with my analogy, it does the opposite of what you think. If you're adding inside the parentheses, you would think it would shift you to the right, but it doesn't. It really shifts you to the left. And one way to visually see that, you don't even have to worry about the asylum with the trig functions, because in order to find your new starting and stopping value for the period of the function, you set what's inside the parentheses equal to 0, which is the starting point for sine and cosine, and equal to 2 pi, which is 1 full period for sine and cosine. And then you can find the new start and stop value based on the phase shift. So we'll see how that works. We're going to start out with just the basic phase shift. We're not going to mess with anything else in the graph, and then we'll put it all together. Starting with our sine, I'm still going to be identifying all of those pieces so that you get used to that once we see a complete graph with a bunch of different types of transformations. So our a value is 1, because we are multiplying our sine value by 1, which means our amplitude will be 1 as well. B value, what are we multiplying by the x? In this case 1, so 2 pi divided by 1 will still give us a period of 2 pi. And d, we are not adding or subtracting anything outside the parentheses to the whole function, so we have no vertical shift. We do, however, as promised, have a phase shift. So we set what's inside the parentheses, x minus pi over 3, equal to 0, the start value for the sine function. Solving by adding pi over 3 to both sides, we get our new starting value to be pi over 3. The right endpoint for our first period will be setting x minus pi over 3 equal to 2 pi. That's the full rotation for the period for the sine function. So we add pi over 3 to both sides. So I'm going to turn 2 pi into a common denominator with my pi over 3. And we get a new endpoint of 7 pi over 3. So with the different denominators, because the period is 2 pi, we still want to split it up into those pi over 2, those quarter rotations, but we're shifting over to pi over 3 to start with. So we're going to need to scale our x-axes a little bit differently than we did yesterday. So y-axis, normal, -1 to 1. And what I'm going to do is each of my black slashes on the x-axis are going to represent pi over 2, and I'm going to make new marks to represent pi over 3. So if you think about fractions, when you divide something by 2, you get 0.5. When you divide something by 3, you get 0.3. So I'm going to make my new mark just to the left of each of my old marks. And these are going to be where I'm plotting the values for my phase shift. So I'm going to do that on both sides. But again, what I mentioned was each of these are still those quarter rotation like they were yesterday. Right? Then we simply plot our points. So this time we are starting at pi over 3, and the sine function starts at 0, or an intercept. So plus pi over 2 at that next red mark, I'm going to be up at my maximum. Next red mark, I'll be back at an intercept, down at the minimum, and back up to an intercept. And off to the left, same thing. So this time at that first red mark, I will be down at a minimum. At that second red mark, I will be back at an intercept, up to a maximum, and back down to an intercept. So there's the phase shift for our first function. For cosine this time, we have a phase shift of 4 pi. So I'm going to run through my a value and amplitude. My b value, period, will still be 2 pi, and we are not adding or subtracting anything on the end of the function. So our left endpoint, setting x plus 4 pi equal to 0. We get a left endpoint of negative 4 pi. And my right endpoint, setting x plus 4 pi equal to 2 pi, we get a right endpoint of negative 2 pi. So you'll see that I already have my y-axis moved all the way over on my graph because 2 full periods with this phase shift will be off to the left. Marking my y-axis, I still have negative 1 and 1 for my amplitude. And because this one was nice and the phase shift kind of matches our period, we can mark all of these with just those quarter turns, negative pi over 2, negative pi, and so on. Now after you get to negative 2 pi, we haven't really marked it beyond that yet because we didn't have any phase shifts yesterday. So make sure you're doing plus those quarter turns. Notice that we've got 1 pi over 2, 2 pi over 2, 3 pi over 2. So it's going to be the odd pi over 2s for the fraction ones. So what I decided to do on this one was instead of doing the negative 4 pi and 1 period off to the right and 1 period off to the left, because that would mean I would need to mark my x-axis for another 2 pi off to the left, I decided to just do 2 full periods off to the right because it was just easier to fit on my graph. So starting at negative 4 pi at the maximum, coming back down to an intercept, down to the minimum, back to an intercept, back up to the maximum. So that was 1 full period, so I'm just going to start the next one off to the right again. So back down to an intercept, minimum, intercept, maximum. So we'll still see the 2 full periods. It's just that we're looking at the phase shift. Instead of being in the center, we put it on the end.